see a few non-dress code sweatshirts going on, that if you guys can take care of that situation for me, that would be splendid. Thank you, Vanessa. Okay. And the other grays are the grade level sweatshirts. I can't read what's on them there. Kalila and Emily. Okay. I figured as much, but I was pretty sure the champion wasn't a grade level one, right? Just giving you a hard time. It's okay. It's all for fun, right? Just having a little bit of fun. Well, there he is. Did you check in at the office, my good man?
I did.
Okay. Thank you very much. So yeah, do we have homework questions that we want to tackle before we start on this this practice sheet? If you don't, that's okay. But I like to start every class with an opportunity to do this, and I'm happy to take some. Evan.
Number 5 on homework 6.
Sure. Okay. So number 5 on homework 6. Okay. Were you able to factor part 2 or number 2? Okay. So if you couldn't have done number 2, there's no way you could do part 5, since you needed to do the factoring part in order to do the solving. Like, that has to be done first. Yeah, that's fine. So I'm going to start by observing that because this is a degree 7 polynomial, we have exactly 7 solutions, which means at most 7 factors. Using the rational roots theorem, I know that any rational solutions to this would come in the form of a factor of the leading coefficient factor of the constant term divided by the factor of a leading coefficient. So since the leading coefficient is just 1, it's really just the factors of the constant term, because if you divide by 1, you haven't really done anything. So we just have plus and minus 1 and plus and minus 2. And then I'm going to go to my graph and see what I see there. So this is probably the most important part before we start doing the synthetic division, is this looking at your graph and in making sure we interpret what we're seeing from our graph correctly, because you can make your life rather difficult, or you can make it a lot easier on yourselves, depending on if you're able to interpret what you're seeing accurately. So the hope here is, after I look at the graph, I almost know exactly what the factored form of this would look like. But sometimes there's a little bit of ambiguity that we'll have to find while we do the synthetic divisions. But the hope is that I'm just about sure how the synthetic division should play out after I've looked at this. So I've typed in my polynomial, and I'm going to reset my window. So since my RRT list goes from negative, or the smallest value is -2 and the biggest value is +2, I'm going to set my x-min and x-max to reflect that, but I'm going to do a little bit past -2 and a little bit past +2, because if there's a bend or a bounce going on at -2 or +2, I want to be able to see that, so I need a little bit past that. And then I usually set my y-mins and y-max at -3 and +3. And now I'm going to hit graph and take a look at what I see. Okay. So I definitely see this straight that's happening. I don't know, it looks like maybe 1.4. I might estimate that. It looks like a little bit less than halfway. You agree with that, Evan? Okay. So I'm going to write that part down. And I know, since 1.4 doesn't occur on my RRT list anywhere, I know that 1.4 is irrational. And I know that from the irrational conjugates theorem, irrational solutions always come in pairs. So there should be another one floating around here somewhere. My suspicion is that, see how this part of the graph looks like it's flat on the x-axis for kind of a long time there? My suspicion is that there's more than one x-intercept going on there. So I'm going to take a closer look at that area. So I'm going to reset my window to go from, say, -2 to 0. And I'm going to reset the y values to really get a close look at what's going on there. So I'll go -2 to 0. And then my y values, I'm going to do like -0.1 to +0.1. I don't know if that's going to be enough or not, but I should be able to. It looked pretty flat on the x-axis, so it's not going to have a really big y-coordinate there, so I know I'm going to have to zoom in a lot. I might need to do more than that still, but and I'm going to, right? Still don't see anything. It's still kind of flat on there. You see that? So that's okay. I'll just go in and make these numbers a little bit smaller. So maybe I'll do 0.01 and 0.01. And I may even have to go smaller than that. You know, like that's entirely possible. So that's pretty good there. I can kind of see what's going on there. If you wanted, we can do one more zoom. I know you guys are kind of far away and it's maybe not as easy to see at the back of the room as it is for me when I'm looking at the computer screen like 6 inches from my face. So let's do one more zoom. And that should be pretty telling there now, right? So now I have a good idea of what's going on in that section. We have a straight here at, looks like -1.4 would be what I'd guess. That's a little bit less. This is -2 and that's -1. So that's maybe a little bit less than halfway. And then we have this bend going on at -1. You agree with that? So let's add those to our list. That was a straight. And again, there's no decimals on my RRT list, so I know that that's irrational. But the -1 is a bend. And since the -1 is on my list, I know that that's rational. So if I make a chart of the possible solution sets here that I could have, I'm just going to group the irrational stuff together into one. So I'm just going to call that negative, this is basically plus or minus 1.4 is that irrational column. I have a spot for my imaginaries and my total, which I know is 7. So bends are used an odd number of times, at least 3. So the minimum number of times -1 could be used is 3. The irrationals, we have 2 of those. 3 plus 2 is 5. So it would mean I'd have to have 2 imaginaries in that scenario. But another odd number would be 5. So what if -1 was used 5 times? Still have 2 irrationals. That gets me to 7 and leaves no room for imaginaries. Now, I don't know which one of these 2 scenarios I'm going to fall into, but I'm sure that it's going to be one of these 2 situations. Either I'm going to get 2 imaginaries or I'm not going to get 2 imaginaries. Are you with me so far, Evan? Okay. So now I'm going to start doing my synthetic divisions. And I know that it's going to work, or -1 should work at least 3 times. So I'm going to start most likely just ripping through 3 synthetic divisions here with -1. But notice here that I included a 0 between the 8 and the negative 15. Why did I do that? Well, if you look at the polynomial, there are no x to the whatever's in that spot. X to the fourth, maybe? So have to be real careful about that. If you had gotten this far and started to do your synthetic division and things weren't working out, the likely culprit there was you forgot to include that 0. So you do need to make sure you're being careful about that. If you forget those zeros, there's no fix for it. There's no recovery unless you go back and you catch that, oh shoot, there's a 0 missing. Okay. Actually, I don't need the calculator anymore. Okay, so let's do these synthetic divisions. Right, that's all right. Okay. Did I write something down wrong? Let me look one more time here. 7, 6, 5, 0 for the 4, 3, 2, 1, 0, okay. 1, 5, 8, negative 15, negative 19. It's like something's going on here where that's not working out. Negative 10 also. Great googly moogly. There we go. So that worked. And then I know it's going to work 3 times, so I'm just going to go again. While I'm doing this, usually I'm going to stop and look kind of as I go to see if I get anything with very few terms left when I'm doing these intermediate synthetic divisions. Here I started with like 8 terms. I got 7. That's no help. I got 6 here. That's no help. So, but if I got something where I just had a bunch of zeros and like 1 or 2 or 3 terms or 4 terms that maybe I could go back to the factor tree, that's something I would want to consider. But for the most part, that doesn't really happen very often. So negative 1 worked 3 times, but if I look at the polynomial that I'm left with there at the bottom, it's still got 5 terms in it. Still really nothing I can do with that. So I'm going to just try to keep going because I know negative 1 might be used 5 times. So I'm just going to try it again and see if it works. If it doesn't work, that would tell me that I would have been finished. But my suspicion is that that was going to work, and it did. And since it worked 4 times, I know it'll work another time. So let's just go ahead and do one more synthetic division. And that went and worked. And at this point, I know I'm done because I know negative 1 could be used 3 times or 5 times. It worked 3 times, and I tried to keep going, and I saw it was going to keep working, so I went ahead and did it 5 times. So that means I have 5x plus 1s, 1 for each of those synthetic divisions able to do. And then I also have the x squared minus 2 at the end. Remember, we have remainder, constant, x coefficient, x squared coefficient. So there's my factored form. Evan, are you okay to there? Yeah. I ripped through that synthetic division rather quickly, but I hope we're okay with that process. Again, like, it's tedious and it takes a minute, and it's, you can make a mistake with the arithmetic, and sometimes it's hard to catch what the mistake is with your arithmetic. But the nice part is you kind of know that you should be getting a 0 for your final answer on those. And if you're not getting a 0, for your final answer. It's a good indicator that, like, okay, I made a mistake there, so I should go back and look at what's going on. So that part at least is nice. So now that we have the factored form, we can go ahead and do part 5 or number 5. And factored form, I can just, since the whole equation or the whole equal to 0, I can go each factor and set it equal to 0. And get some solutions. So the x plus 1s, those are easy to solve, right? We're just subtracting 1 from both sides. X squared minus 2, though, is quadratic, but there's no x term. So I know that I can solve this one directly. So I can like add 2 to both sides and then square root both sides. When I square root both sides of an equation, it creates a plus or minus. So I have 1, 2, 3, 4, 5, and then because of the plus square root 2 is solution 6, and minus square root 2 is solution 7. So there's my 7 solutions that I was expecting. And just as an aside, if you type square root of 2 into your calculator, that's about 1.41. So that was the x-intercept we saw on the graph that we knew that we couldn't use to do the synthetic division. So there it comes, and you can only find those by factoring. You're not going to be able to figure that out. What the radical is anyways, what that actual solution is. You can just get an approximation. Looking at the graph, you won't be able to get the actual number without doing the solving process. So you'll have to have factored everything. Does that feel okay, Evan?
Yeah.
So the hard part is the factoring. Once you've got that factored, the solving is basically a chapter 4 or earlier problem. Which is, and even so, like the hardest kind of factoring or solving you're going to get is still pretty easy versions of chapter 4 problems, right?
Yeah.
So it's, the hard part is getting it factored correctly. But yeah, feel okay?
Yeah.
Good. Yeah, no problem. Do you guys have some other questions from homeworks you want to do? It's okay if you don't. We can always come back and take stuff again later or next time. All right. If you change your mind, you can always talk.